Good morning, everybody, and welcome to another great Land Effects webinar. My name is Jake Lott. I am going to be moderating this webinar. We have a really special feature here from yours truly, Jeremiah Farmer, who's going to be going a little bit behind the scenes talking about AutoLISPs and even giving a little demonstration on some stuff. Before we get started, I want to go over a few minor housekeeping items. You should see a Q&A box or option there at the top left of your screen, as well as a chat window. We want to make sure that we ask questions in that Q&A box so that we can answer those as they come in. Any other little banter that you got going on, leave that to the chat window. You might see that you're in full screen mode, so if you go to the top right of your screen, you'll see a little minimize full screen so that you can do other things if you need to. So without any further ado, I want to kick this over to Jeremiah.
Hey, thanks, Jake. Everybody, let's get going and talk about some AutoLISP. As for the tagline there, that was more intended as a hilarious Simpsons reference than saying AutoLISP is actually the cause of problems. But it is admittedly a little maligned at times, and that is probably due in no small part due to the fact that it is some 60-year-old programming language shoehorned into AutoCAD and hasn't been updated in 20 plus years. So it's a little archaic at times, but it's still really cool and is very capable. And so that's what we're going to be talking about today, is what can be done with it and why it's frankly awesome. So here's me. I'm a self-taught programmer from a young age. And when my dad moved his office to AutoCAD when I was about 16, we started fiddling with that, and I started getting into AutoLISP. So it's been 20 plus years, actually. I think technically closer to 30. And my main advice is to be patient. It's not a very forgiving language to get into. But it is really well suited for certain things. And so ideally, if you're using it for something it's well suited for, it's actually fantastic. And so keeping that in mind. Well, let's start with, of course, our agenda for today. I'm going to be covering the basics of what it is, what you can do with it, and do's and don'ts, ideal development environment we're going to show, and we're going to actually make a real function in real time, and so you can see how it all comes together. What we're not going to do today is that on the right. If this ends up being successful, if you guys chime in and you say, yes, please more, we can have follow-up webinars on intermediate and advanced. So in terms of things like dialog boxes, cloud data, integrating into the ribbon, things like that. Please don't ask questions about that today. That's for a future session. So now let's start with what is AutoLISP. Well, it is by definition, it is a command line interpreted programming language. Now what that means is it's not compiled somewhere else and then run as a binary executable. It's fed line by line to the command line of all places. The AutoCAD command line can interchangeably interpret commands, like if you type polyline or AutoLISP. And so what that means is it's basically a really good companion to the command line. It means that AutoLISP functions can very easily run AutoCAD commands. They can be inserted as the values for prompts for commands. And so you can mix and match, you can test your code line by line at the command line. So it's actually a really, really ideal development environment, specifically a development environment for working inside of AutoCAD. So assuming you're going to be dealing with objects that are in model space or paper space, that's where it's really, really well suited. And then of course at the upper end, you can have a ribbon and database access and download files and of course be a full complete application, even for instance like Land Effects. So it is really powerful, but of course for our perspective, we're looking at the very lower end, which is where is it best suited, and that's thinking of it specifically via the command and what would be some cool things to have at the command line and some real simple little tools to help you with AutoCAD commands. Let's start with literally my favorite part about Lisp. Lisp is a language, dates back to, I believe, the early 1960s, but I know the 60s in there somewhere. And the most beautiful thing about it is that it's not its own made-up language. Literally every other programming language in the world makes up its own unique syntax and has things like curly braces and things. Whereas for Lisp, they said, well, let's just use mathematics. And what do I mean by that? Well, I'm going to hope we all clearly understand what 2 plus 2 is. But let's break that down. You have the operator, which is the plus sign, and the 2's are the operands, right? Well, if you've ever used a programmable calculator, you know that you need to type in equations like this. So you've got your parentheses, which is mathematical, of course, encapsulating this entire statement, if you will. But the operator is first. So encapsulated within the parentheses is an operator and then any number of operands. And by any number, I mean that's what it lets us do, lets us scale it up very fluidly. And this is the core conception of the language of Lisp. And so there's the spaces in between each item and the parentheses that separate it. And then, of course, you can stack them like this. So let me break this one down for you. In this case, we're using the AutoLISP statement setQ. setQ stands for set the quoted variable. So what that and so it's a little easier to just memorize as setQ rather than what it means for, but in this case, I'm setting a variable, and the variable is radius. I want to set the variable. I'm inventing a variable, radius. So I want, from this point further, I want AutoLISP to treat the variable radius as what? Well, we can see it's the contents of these parentheses here now, isn't it? Which is 2 plus 2 plus 9 plus 7, that's 20. So after this line, if I was to copy and paste this to the command line, the variable radius now equals 20. Well, look at this. I'm hoping this is really obvious, but the beauty is we're moving right along. That's a giant conception in terms of a programming language, and it's just so much simpler than almost literally any other programming language out there. Since I'm talking about setting variables, we're going to need to talk about data types. This too is another wonderful thing about AutoLISP. There are only four data types in AutoLISP, and they're all pretty easily understandable. If you're new to programming, oddly enough, the simplest one is probably the most obscure. A Boolean data type is just simply true or false. In AutoLISP, T is the symbol for true, and nil means effectively nothing, just nil, nothing, not true. There's lots of times you need to know whether something is true or false, if the user entered a value, if there's any objects in the drawing, on and on and on, very commonly with an if statement. But I need to know whether something's true or false. And then my other data types is literally just this: integers, which we know as being whole numbers without any decimal precision. And I included the largest 8-bit negative integer, and that's the largest 32-bit positive integer that AutoLISP can deal with. But the beauty is I don't need to declare it as any of that. It is an integer, and AutoLISP takes care of it from there. Real numbers, of course, we have precision. My favorite real number, and hopefully yours, everybody loves pi, but that's at the full precision of AutoLISP, some 14 decimal places of precision, which is phenomenally accurate. So you have a high degree of accuracy and then the very simplicity of these data types. And then, of course, a string could be a message, could be the name of a layer, and so on. I'm going to need strings. Well, there's one thing you might be noticing is, well, I need more data types than that. And that's where there's another sort of a data type, a list. So a list is, and of course, being called Lisp, the L in Lisp stands for list. It's going to be something within parentheses, isn't it? So within the parentheses here is a list. And what is in this list? Well, we have 4 values, and they are what? They're integers. Again, all my data types are only those 4 data types. So the way I get complex data objects and things is through lists. So this is literally a realistic list. This could be values that a user has already entered. I'm just creating an arbitrary list of my own creation and storing whatever values I want in there, in this case, 4 sequential integers. How about this, though? Here's a very common one. Inside this list is now 3 real numbers. And guess what? That's a point. At least it can be a point. See, in most programming languages, you would have to declare a variable as a 3D point. But in AutoLISP, a point is just simply a list that has 3 real numbers in it. And so it's at once both phenomenally flexible, but also a little challenging to the programmer because you're in charge of it, and you're also in charge of policing it and enforcing this and making sure you didn't accidentally have a real number, a string, and a real number. That's on you. But it's phenomenally flexible in that regard. And then the next level of complexity for lists is, as you can imagine, I can do a list within a list, within a list, within a list. This is a very special kind of a list within a list. You can see I have my outer list, and then inside I have these. These are called dotted pairs. The little dot there means they're dotted pairs. And this is the best way to understand why it is this way is remember that this was invented in the 1960s. So this is the literally most efficient way to use as little memory as possible. And so if I want to store complex data, I can do it this way with just simply an integer letting me know. So again, it's up to me as the programmer. Me as the programmer, I'm going to remember that my 2 group stores my message, and my 3 group stores this real number that I'm using for something, and so on. And so the way AutoCAD treats this basic structure of Lisp is this is how you access entities in AutoCAD. Well, through AutoLISP, of course. So I have my entity. There's my, my full parentheses out there and my dotted pairs. And every entity, it's going to start out with a 0 code. The 0 code is what entity type it is. This is obviously a line. And what comprises a line? This is everything that's necessary to create or modify and accessing a line is I need to know where it is. So the 67 code, again, minimum necessary. That's whether it's model space or paper space. So 67.0 means model space. The 8 code is the layer. So it's a line that's in model space on layer 0. And then here we have the 10 and 11 code. And look at that. See what's after the 10 and 11? I've got a start point and I've got an end point. Of course, once I trim the 10 off, that's how I would suddenly turn that into a point. So again, it being so very flexible and very simplistic. But as you can imagine, a lot is then, like I said, on the programmer. But as long as we're talking creating a line, let's access the real beauty of AutoLISP and do it this simply. I can fire the AutoLISP function called command, and now anything after that is just simply thrown to the command line. So in this case, I started the line command, as if I just typed these characters at the command line. Then a space in between each thing will be treated as a space at the command line. So this is going to be interpreted at the command line as if I typed a line, hit space, it then entered this variable. Hopefully I set that to an actual point, and hopefully this is also set to one of those points that I just mentioned previously. And then lastly, an empty string here is treated as if I hit enter and ended the command. So the beauty is I created a line in the AutoCAD model space according to these two previously defined points this easily. And so it's very, very light in terms of code and very quick. And also, I can just simply type the command at the command line. Oh, okay, those are the different prompts. Wrap it up in a command call and assemble my code very, very quickly. Another way to do that is let's throw in the get point function. And so if I was to also just either copy and paste this or type it at the AutoCAD command line, you'll see that get point is a function that prompts for the user to select a point. And so the way we interpret this is it's just like, again, it's math. So if this was a mathematical equation, we would solve these inner parentheses first, and then we'd solve the outer parentheses. So it's going to be interpreted the same way. If I copy and paste this to the command line, AutoCAD will prompt for a point, and then it'll prompt for another point, and then it will pass the values of both of those to this command line call to create a line. Not necessarily super usable, so let's take this to the next level and continue to show what we can really get away with. Now I'm creating a function, and that's defun. That stands for define function. So that means that I'm creating my own function, in this case named draw line. The empty parentheses here just mean that it doesn't accept any additional parameters. So I'm creating my own function named draw line that ends down here. And the semicolon here, in case you're wondering, that's a comment that's only visible to you, the programmer. The computer ignores those, but they are very much required, as far as I'm concerned. Always put trailing comments, because otherwise you just see a trailing parenthesis and it can be confusing. So you can see how that's a personal choice technically from the programmer, but it makes it more clear to see that this function ends here. But what does this function draw line do? Well, we kind of know what it does, right? It sets a variable point1 to get point, prompts for a point. So now the variable point1 is whatever the user selected. It then starts a command line call line, feeds that point to it. Oh, whoa, it stops. So this is the real beauty of AutoLISP. This command line is active. Even though I ended the parenthesis here, it's still active. I can go off and do math. I can do any number of lines of code and come back to the very same command line and finish it off with the second point and end the line. And in case you're wondering what is going on here with that math, I calculated point 2 with some polar math. So it starts from point number 1, goes to 0 degrees, 100 distance. So this little function, summing it up, it prompts for the user to select a point and then immediately draws a line at 0 degrees, 100 distance from that point. So very quickly, I could do rather complex things. Let's talk a little bit about function basics, because we're getting there quick. I mentioned defun creates a function. Well, there's a very special kind of function, and that's the one that starts with a C colon. And that becomes a new command that you can type at the command line. So I could type my function. It doesn't even have to be upper or lowercase, but I could just type my function without any parentheses or anything. And it will then do this. And then this too is another strong convention, although this one is technically optional, is following along with this schema. What is recommended is that you choose a prefix that is either, for instance, your initials or your company's acronym or something. And so for the rest of this webinar, I'm just going to say XX colon. And that indicates that it's not a AutoCAD function that's built in. It's my own creation. So it's very immediately understandable and readable, and it'll never conflict with anyone else's AutoLISP because that should be unique to you. So this is just very quickly an example of the user could type my function at the command line, and it will call this custom function that you've done that does any number of things. You have to have if then. If then, we all know and love as a concept. This is what it looks like in Lisp. If this statement evaluates to true, then it will do this condition. If this statement evaluates to false, it will do the second condition. And then, of course, I can pass a parameter. This one doesn't pass a parameter. So I'm just kind of showing some different things here. I have to be able to have a while loop. So you can imagine, this also is a very good example of how readable code can be. The most complex thing imaginable could be wrapped up this simply so that it's very understandable. While, and then have a custom function, while the user is clicking away, well, what do? We place objects, we rotate them, we whatever. And so it's very readable. I don't have to read through a whole chunk of code to figure out what the basic structure of it is. So this is also an example of how you should strive to write your code. And then lastly, just another one, this would be calling our custom function, make circle, and passing some variable names to it. Again, just stressing the readability. Because it has my XX prefix, I know it's my function, and I named my variables very clear. So I'm hoping that you would guess that, oh, I bet this function will make a circle at that point of that radius on that layer. And so again, code is all about readability. So we can now talk about vocabulary. This is a language. You should treat it like a language. Learn your vocabulary. I'm going to pull that up right here. Best way to get into any programming language is to just read all the various functions that are available. And luckily, there's not very many for AutoLISP. Like I say, ignore the ones that start with VL for now as we get into those. But there's not a whole lot. And I just recommend, before you're going to go programming, just literally read through all the various functions so that you've just read them and you tend to then come back to, oh, wait, I think I read something that does what I want. Let's just say, let's look at the different math functions available, right? I can plus any number of numbers. I can subtract them, multiply, divide. Oh yeah, I pretty much assumed it would have that. Bitwise, don't know what that means. But you come back later and come to something where some forum post says, oh, do the bitwise operator. And you're like, oh, I think I read that somewhere. And I can go down, if I scroll down to the bottom, I can go and read more about that. And it's all HTML. This is a heck of a lot easier than how I had to learn it. So it's just literally a lot easier. But also, like, you have ones like this. Get the absolute value of a number. So you can imagine if you didn't have a function of absolute value, you would have to have a if number is less than 0, then multiply it times -1. And so you might accidentally write that code thinking, oh, I have to return the positive value, without realizing, oh, I have an absolute value function that I can just simply use. And so you get familiar with your various functions that are available over time. But here I'm also recapping a lot of the basics, the setting of a variable to a get point. We did the get point. If you read about it, you'd see it does accept an optional prompt. So you can name the prompt whatever you want. You can even get funny if you want. There's other get functions though. Get a string, get a corner, get a distance. So again, you're just kind of learning these different vocabulary. We're going to need to access the objects in AutoCAD. So that's int get, which is for entity get. It's going to get the entity definition. In this case, the last entity. So this statement, if I just simply copy and paste int get int last, it'll return the entity definition of the most recently created object in model space. That's obviously very handy and very slim, again, in terms of the code. The other int functions, int cell to select one, int mod to modify one, and int update to update a more complex object. So again, you'll read up on the int functions, just be aware of them. And again, you start copying and pasting them to the command line, typing the command line. It's a very fluid learning environment. You need to be able to give an alert message to, don't click here, no such object, things like that. I need to pop up an alert message. I need to be able to print to the command line. That's a very, very important one, because the more verbose you can be at the command line, it will help you debugging and it'll help the user. Certainly as you're writing code which might not be fully developed, you want to put in lots of messages. And then of course, as we're dealing with lists, as you can imagine, there are a lot of ways to transverse and process a list, and I just threw in a whole bunch here. I can create a list, I can take the first element, everything but the first, everything after the first, whatever that is, reverse it, last it, list it. So, and also just kind of throw it in kind of a silly little Lisp line here with all the trailing parentheses, also showing it can get unreadable if you do this. So don't do that. And I'll get into that next. I'm going to take this down a bit, and let's think about writing code. I argue that it certainly feels that every programmer out there thinks that code should be designed like this. That you've got these clean lines. It's built for speed. There's not an inch of wasted space on it. It's not utilitarian, it's built for speed, right? And I argue that's the entirely wrong way to think of it and the wrong way to write code. Instead, think of it this way. If you have a Mach 2 fighter jet, you have to maintain it. This is how you should think of the code that you write. Access panels, maintenance panels. How are you going to maintain this thing in 5 years, 10 years, 20 years? So all of these, this isn't shot up with bullet holes. This is an actual F-15 fighter jet with all of its maintenance panels removed. So look, we can get to the machine gun very easily. Things like that. So think of that as your overall philosophy when you write code. And I have an example of that. This is an actual example from a chunk of code of LandFX. This is our copy along polyline function, a little snippet of it. And just multiple things to kind of point out. But the first is just this, my little access panel. This is inside of a complex loop that is intercepting the mouse as the user moves it. So it's very difficult to debug. But all I have to do is remove these comments here, and suddenly it'll spit out all this information while I'm moving the mouse, which helps me debug it. And it's very clear this is the access panel. Also, the general construction of this. Look at all the blank lines. So if I needed to inject some additional testing code, I can very, very easily. My naming of variables. I have an underscore prefix for the super globals, a just uppercase for the globals. Hopefully they're fairly understandable that I have the global spray angle, but then the lowercase SA is the localized spray angle that then is divided by 2. And of course, I mean, we must, of course, discuss the comments. Comments almost on every line. It's readable code. It's maintainable code. So let me show you the alternative. Fun little trick here. What is the code on the left doing? I wrote this code. Oh, you punk 19-year-old kid. I can't believe this. He didn't put a single comment in here. Okay, I can see there's a P-line command. And I can see A for arc. And down here, it's closing that polyline. But we have a while loop and then another while loop. Nested while loops. And inside all this looping, look at all the math that's happening. some of it is understandable. This is obviously Pythagorean. A squared plus b squared equals c squared. Okay, but then it's taking an arctangent of that. Um, we've got variable names that are impossible to figure out. O1, what the heck is O1? What's R versus H? Um, 20 years later, I wrote this code and I literally don't know what it's doing. You know how long it would take to figure it out? As opposed to the code on the right, one of the more recent pieces of code I've written has a comment at the top just saying what it does. Comments on virtually every line. Attention to having the variables be readable. You could say these variable names could even be more descriptive, certainly. But little things like I put in an at in the comment to let me know where I left off. So pending is I need to add true color support to this. That's right where I left off. But I can jump in and maintain this incredibly easier than this one on the left. So we're going to get in. We're going to write some code. Doesn't that sound exciting? The nice thing about AutoLISP is a very low barrier to entry. You have AutoCAD, so I mean that's all you really need. But you're going to need a code writing program. Use UltraEdit. They have a AutoLISP Word file. I'm also going to provide mine, which I prefer to theirs. Will be available with this webinar. And then set a nice code writing font. I don't like the default. I used Lucida Console for many years. This is Source Code Pro, which is the new phase among all the rage among HTML programmers these days. But you can see it's very easy to tell the difference between an O and a 0 and a 1 and a lowercase l, things like that. You need a good code writing font. But both of these are free, and UltraEdit always set you back like $70 or something, and that's it. That's all you need to buy. You set your support file search path. You're going to need a command to reload your code because you're going to be reloading it over and over and over again. So for my example, I'm going to assign RRR to reload, reload, reload. And you're going to need this very simplistic error function. And I'm going to show you more of exactly why and what that does. But it's all about firing this backtrace command, the VLBT backtrace command. I'm going to show you exactly what that does and why. One last thing before we get over to actually write some code is as you get into code, you're going to need help. If you Google AutoLISP forums, you're pretty much going to get all of these. That's pretty much the order I would put them in. If you do get into these forums, please, please, please take the time to learn proper forum etiquette. The last thing you want is to be discouraged by doing something wrong in a forum. As you may have heard, some programmers are less than lacking in social skills, and they might, call you a name or something if you do something wrong. So just learn the proper forum etiquette first. But these are great forums. Lee Mack is, I would say, without fail, the most brilliant AutoLISP programmer out there. His site is fantastic. He has tutorials. He has really, really, really helpful source code, great tools. Just fantastic to bookmark that site, but for all of these examples, whenever you're pulling code from anywhere, like I mentioned, please beware of bad code writing habits. The better you can set good habits at the outset, the better you'll always have good code habits, which is the ones I've mentioned, access panels, comments, things like that. We're going to get into writing some code. I'm going to just ask Jake real quick if there's a question that we should stop for.
We have not had any questions yet. I think we have all been trying to keep up with learning this code. It's very, very cool. So just one friendly reminder, everybody, use that Q&A section if you have any type of question that you want to go over.
Okay, great. Let's do this. So here I am. I have my UltraEdit. I've installed that AutoLISP Word file so it can interpret Lisp now, and it knows what begins and ends a function. So I can roll things up like that. It's a just natural development environment, and it's the best made. So that's why you want to do that. I've got my AutoCAD over here, and in my options, my support file search path is I've got the folder where this Lisp code is saved. So once I've got my support file search path, good. I've got my reload function defined, and I've got my error function defined. So I'm going to show you how this all comes together. This is the function that we're going to be playing with, just simply called test. And I started us out by assigning my error handler to it. This is how you do that, is everything after a slash is local to the variable. So my local error handler is set to this error handler here. And I'm going to show you exactly how that all comes together. But first is I just put in a hello world. So let's just load up my code. It's loaded, and it lets me know I can type test. Boom, I've got my hello world. So we are, right now, AutoCAD is dutifully right here. It has presented this alert message to the screen, and it's stopped right here, waiting for me to click OK. So if I click OK, it now says enter string. So it moved down here, if get string, enter string. So now it's waiting for me to enter a string. And I'm going to go ahead and just hit enter. Oh, look at that. I called new function, and I got all this blah, 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 right? But this is why I want this helper function, is so that I get this debugging information, as opposed to if I don't. Let me just show you. If I don't have my helper function, and look, I still have my reload. So I've reloaded. Now I can type test. There's my hello world. Okay, great, great, great. There's my get string. Okay, I'm going to just hit enter again. Oh, I didn't get all that handy debugging information. It just says error, no function definition. And in fact, the same applies. Instead of hitting enter, I'm going to hit escape. And now it says error function canceled. Well, that was no fun. And so here's the problem with this is this error handler, poor little guy, overstressed error handler that he is, like my comment says, in addition to handling actual errors, every time I want to use exit to exit a function, and every time the user wants to exit a function by pressing escape, it will come here. Both exit and escape are effectively treated as errors, which is really annoying because you tend to not want these error functions here, and you want this really cool verbose output when it's an actual error. So it just means my error handler needs to be as simply constructed as this. If the error message string is not function canceled or quit exit abort, then do the backtrace. That's all it's doing. So it's just giving me my environment that simply. I just wanted to make sure we're clear on that. So I can save that, and let's get rid of my hello world, and let's get evolve this code, and let's write some code. So what are we going to do today? We are going to do, been reported to me many times, people go, I'm here in AutoCAD, and I got this XREF, right? I got this line in the XREF, but I want to change the color of it. And it's a real pain. You got to type XList. I got to click on it. Now I know the layer. Oh, great. It's all lowercase. Thanks, XList. That was totally unhelpful. And now I got to go over to layers. I got to find that layer. I got to change its color. That's just a pain. So let's make that better. Let's write some code to select an object and change its layer. So I said we're writing code, but what was the very first thing I wrote? A comment. This is exactly how you should write code, by writing comments. And in fact, we are going to start by just drawing that out in comments. So we're going to say I need to select an object, right? I'm going to need to get its layer. I'm going to need to get a color, and then I'm going to update that layer, right? I'm writing this pure English, I have no idea how I'm going to accomplish this in code. And that's exactly how you start. And the official term for this, and it's called pseudocode, is that I can get this more and more closer to code. But what I like to do is just start out with my overall outline and then make a copy of it. And then I'm going to start writing the code in here. But this way I keep my overall comment and I keep the overall outline all up here at the top. And that's just going to be easier when I come back to maintain it. So I'm going to need to select an object. And, you know, I think you maybe we're following along and kind of saw that there's that int cell. I can select an object that easily, right? And I can test that at the command line. Int cell, and I can click on that object. Hey, I got my object. So I'm going to set that to a variable. And what's a good name for that variable? Well, you know what? We're not going to belabor that. I'm going to say entity selection. Sounds good. Okay, and then I need to get its layer. Well, let's see. How am I going to get its layer? Well, I have to get the entity definition, don't I? I kind of forgot that step. Well, so let's see. I'm going to set that entity definition. We'll call that int. And this is where we need to use int get. And the first element of this list, not the point. So the first element of a list is car. So in fact, here's another little nice trick. I'm programming kind of linear in a linear fashion. And here's the end of the function. So the last statement here, the results of it are going to be spit out at the end. And I did that on purpose so that I can RRR to reload, type test, select my object. Boom, look at that. So now I know that my int variable, I made a oopsie doodle. Always, always, always declare your local variables. Now, things will still technically work. It's just best practices. So you want to always be careful with that. And of course, super best practices right here, you should be saying what those variables are. So, you know, you kind of start some comments here. And so that it's very, very clear, again, to maintain. How you're going to maintain this is with an instruction manual built into the code. Okay, but I've got the entity that I clicked on. Great. Now I need its layer. Well, I happen to have thrown in this DXF function for you. Because like I said, you know, all these are these dotted pairs, remember? So these dotted pairs, so a real common thing you need to do is I need to get that backend value for a particular dotted pair. And that's what this DXF function does. So that means I can set my layer variable to DXF8 of that entity. And again, create that local variable. And now I can kind of continue testing. Great. Type test. I click on it. Got my layer name. I'm moving right along. The one thing I want to show on that DXF is, again, I've got this. So I'm just going to throw this over and show you what that is. Like I said, this is where you as the programmer are kind of in charge. So how did I know that the layer was 8? Well, you know, I could come in here and learn this, that in my entities section, my common group codes for entities. So this is where it's, you know, it's up to you to kind of learn these things. This is where it gets a little unfortunate, but you learn like the layer is the group 8 code. The line type is the group 7, your group 6 code. And whether it's visible, making invisible objects, by the way, is really fun because you can mess with people that way. But anyway, so that's why I knew that that was 8. And in fact, would that be something to comment? You know, I mean, it's kind of obvious, you know, so, but that's, again, should you plan on always having a comment on each line? I don't know, but I'm going to kind of come back and deal with that. I need to get, I got the layer. Look, I kind of missed a step. I got the layer. I missed a step of I need to get the layer's color. Now, this is a great example of something where you're like, well, how the heck am I going to do that? And you might need to bounce around on the forums, and you might find out that you can do that with table object name. And for the layer table, whoops, oh my gosh, if I can type right, I can return the layer entity, which means my my object of the layer, Olay. I just like saying Olay, so I love using that as a variable. So again, I should be prepping these Olay. I would like that is the object of the layer as opposed to layer, which is the string layer name. This is being meticulous, being meticulous. So I've got that layer definition. Whoops, sorry. I meant to just save that. And so I'm moving along with this code. Okay, I've got the table object name. Oh, that's actually just the object name. I need to get its definition into Git. And actually, did you see the difference there? The other thing that the AutoLISP Word file offers is if I mistype the function, see how it's in black. And the color is up to you. That's it. That's all defined in there. So you can define more vibrant colors if you wish. But so now I have my layer. Well, and I totally forgot. I should have said I need to get the layers color. That would be kind of handy. So I can set it to DXF62 Olay. Again, something I would have found out. But let me see if I didn't know that. Let me just comment that out and just show you if I didn't know that first. Here is the definition of, look at that, zero code. Remember, the zero code is what the entity type is. It's a layer. This is the layer definition. And here's all the information that makes up a layer. 62 happens to be its layer color, which of course I would have found out if I'd gone to this documentation here and looked up a layer object. So I know that the color is the 62. I'm moving right along. Now comes the really interesting part. How am I going to get a new color? And again, well, I research it and look around, and I might find this really cool gem. AutoCAD color dialog. How cool is that? I mean, you can, that simply, I can prompt for the user to give me a color. And look, it returns the color number that I pick. How cool is that? So like, it also just makes a really simple AutoLISP function look cool because people will think you made this and you can, kind of pass it off that way. So, oh my gosh, how neat is that? So that means my new color is my color dialog, and I'm going to pass it the old color. So now I'm moving right along. Like I can even kind of save this again. I can test this again. I click my object. Okay, it's highlighting the color already. I pick a different color. It returns 71. Oh my gosh, I mean, like we're almost done. I just need to update the layer. And here's another one. Okay, again, something that would need to be learned, but I would learn that what I need to do is modify this layer object. And the way that works is I use substitute. Substitute brand new 62 code, the old 62 code. And then I'm going to update that darn layer. Oh my gosh, how cool is that? This is going to be super fun, right? Is this going to work? Is this going to work? Let's find out. So I select my object. I totally pick a different color. Wait, it says it did it. Look at the 62 code is 50. It modified layer 0, and I clicked on an object in the XREF. The XREF is on layer 0. Well, okay, a little bit back to the drawing board, right? Let me just reset my layer 0 because I don't want it color 50. So, okay, what's going on here? Well, turns out it all comes to this. When I did that initial entity selection, it grabbed this entity, which is what? It's an XREF. I want to grab the line in that XREF. And again, maybe go back, read the documentation, go to the forum, and find out there's a nested entity selection function available. Welcome to the wonderful world of being a programmer. You might even have purposely meant that, and you're debugging line after line of code, and you just forgot to type nintcell instead of incell. Yeah, that's welcome to our life. But let's try it now. I fire test. I click on him. It's showing cyan, so I know that worked. And I could, of course, just copied and pasted some of these to the command line to confirm line by line. That's the beauty. Okay, let's change it to red. Changed it. Darn it, I swear it changed it to red. And if I was to look in layers, I would go, it is red. I do a regen. Oh, now it's red. And this is just a little quirk. When I'm modifying a layer that's in an XREF, it requires a regen. So let's just do this so we can get out of here, right? I'll fire a darn regen because I want this code to work and I want to move on with life. So I can pick yellow. It fires a regen. It changed it. Even though that's an object in the XREF, change that layer color that quickly. I can now go around. I can click an object in a block that's in the current drawing. It changed that. This is a pretty fun tool, isn't it? It's very usable. So, the tail end here is there's a few variables I missed. Forgot color and new color. But where we're going to end up with is I just kind of laid these all out pretty flat. There's no error checking. There's no what if I don't pick the color? Things like that. So for instance, if I do test and I don't want to pick an object, so I right click, it fired my error. Let's see what error it fired. Int get nil. Okay, let's see what that is. Well, that was int get here. Oh, I see. When it prompted for me to pick an object, I right clicked. And as the documentation says there, that'll return nil. So that means the variable e cell was set to nil. Car of nil is still nil. I can even test that to confirm. That's the whole beauty of this. Car of nil is still nil. Okay. Int get nil is obviously my error. I can't int get nil. There's no entity to get. So I need some sort of error handling here. And now I think about it. Well, I might not select an entity. I might not pick a color. And so here's where you get to kind of program flow and organization and all of that. And I'm just going to do something really simple is I kind of know it's basically if everything works, keep going sort of a thing. So I can say if and put all of this into an and. Oh, how about I don't actually accidentally put in a weird character. I'm going to indent all that so it looks nice. Right? And so what I want is this. And in fact, I play as nicely as possible to my UltraEdit interface so I can roll this up very nicely. So if this is true, and this is true, and this is true, and this is true, and this is true, that means any one of these fail, I'll get a nice clean exit. But lastly, it turns out I want to modify the layer and then fire a regen. That's two things. And I can't say two things because the structure of an if-then is only one thing. So I need to wrap these up in an arbitrary group. And if you look again in the documentation for if, you'll find progging, this old Lisp statement to just roll up two things arbitrarily. And also proper being meticulous. You should also put in the otherwise. I love doing this so that it's very clear. And in fact, maybe put something here. Make room for your comments. And so, all things are true. Go ahead and modify. So I have this. Otherwise, and in this case, really not much to do. So just exit, And so it's easy to see if I roll this up now. I can see the structure of what's going on and even add more comments. If user selects object, get color, get new color, right? All this stuff, put in a comment so that when it's rolled up like this, I can see what's going on. And then, saving it now is basically my kind of sort of final version is that, whoops, I didn't want whatever that was, test. And so if I don't pick a color, if I hit cancel, it just ended out, oh, but it says nil. How about one last thing? Is it ended nil because that's true. Nil is the result because not all of these were true. So it returned nil. And you want to think about it, even when it's successful, it still returned something. So here's what we usually add at the end. We add an empty print to the command line, which is called a clean exit. So what that does is if I click cancel here, and I just get a nice clean exit. A little bit of housekeeping, you know. But there's my function. I just want to, I'm trying to think if I was anything else I wanted to real quickly mention, but I think that was it. So I'm totally open for some questions.
Great. That was very cool to watch, very fast. So we've got a couple. Kurt actually is asking if you recommend using an IDE, an integrated development environment.
Yeah, they have one. They have this one, and it's horrible. It, the main thing is Autodesk stopped developing AutoLISP in 2002, I think, or 2000, right in there. And so this is just really bad. It's very difficult to operate. Yes, it has your IDE tools of stepping into and over and breakpoints and watches, but it's far more difficult to use than to just simply use something like a good code editor, like, of course, UltraEdit. There's other, you look on those forums, other people like Notepad Plus, and there's some other really good code editors. And then that means it's up to you to kind of do your IDE functionality. But for instance, JavaScript is really the same. There's not, it's very difficult to program in JavaScript. And so certain languages, you end up just being very used to just go slow and meticulous, put in your own breakpoints, put in your own, like if I was debugging this after the fact, I could see I've got the object layer definition. I could go ahead and drop in a print OLay to the command line. So instead of using an IDE that's going to have a watch panel, so now when I come over here and I'll just go ahead and cancel out, you can see it printed to the command line the contents of that variable. And so then, like I mentioned, with an access panel, make it an access panel. There we go. So maybe put in a couple of these access panels and leave them there. It's not doing any harm to leave that there so that when I come back to debug it, I can just remove that comment really quickly.
Cool. Yeah, and actually you touched on Notepad++. Steve Patton actually mentioned that is a pretty good Lisp programming deal, and it is free as well. So,
oh, great.
And then a good question from Camilla. She's asking if all lines inside of a block are on layer 0, how would you adjust this Lisp?
Oh, that's a good one. Oh boy, let's see. That's a very good one. Yeah, we got a couple minutes. I can do that. I'll do that for you. So we have this object here. We got the layer here. You know what? It would be an access panel, frankly. Because that's going to show off things. I'm trying to think if I quickly have a block that's on layer 0. And I can do that fairly quickly. I know, there we go. I'm just going to drop in a valve. Okay, so, because this guy, isn't he on layer 0? He's on layer 0. What do you know? Great. So he's on layer 0. And so that is a great point, and so that would be like right here. Whoops. So that would be right here. And so here, mark, again, starting within comments. Oh, what if this is layer 0? What you would have, what would I do? And again, it's not a programming thing, but what would you do? And, maybe one option is you could just alert to the user. But in a better way, you would want to, uh, ideally, right, you want to modify the layer that the block is on, is what you'd want to do. Well, that's, again, to deconstruct that into code, we'd have to unwind that. So we'd have to, okay, what I have to get the block, and so then I could get its layer, and then making sure that make sure that works with the int mod that's down here with the rest of this. So it's a few steps, and what it essentially comes down to is a craziness of the nested entity selection. And so it's a little too complex to wrap up in this session, but I'll just show you. When I clicked that nested entity selection, this entity here is the deepest entity in there, which is the line inside the block. But it also returned this one over here. And in fact, if there was multiple ones, there could be a whole list of other entities. This entity over here is the next level up between that, which is, there's only one level in that case. There's the line in the block, and then there's the block. So what I would have to do in that case is I would have to, like this says, to get that block, there's no other way to do it. I'd have to loop through the objects in the nested entity selection to find the block. So that's, as you can imagine, that's going to be a little complex. And what I might do is then, just as an example, maybe that would be a good function. So maybe even some parts of this could get rolled up to a function. And so that's one last thing to ponder, is what if I was to create a function that said get entity, right? And the contents of that function was just simply these two lines of code. So now my code's a little cleaner, and I have this sort of helper function that I can use in any possible instance. So that's how your code kind of evolves, of course, over time. And I see we're done with questions. Well, I hope you enjoyed this. And like I said, if you'd like to have this go forward to an intermediate and an advanced, please let us know. We'll get that scheduled. I'm happy to do that. We just are going to, of course, they're going to tell me if I went too fast, it went way over anybody's heads. So we'll find out. But other than that, please have a great weekend, everybody.